Welcome back to another episode of this Dynaco ST70 restoration project. This is episode 5. If you missed the last episode, click in the link above here. It will take you to it. If you haven't clicked that subscribe button yet, click that subscribe button now and that little bell below on the bottom right. In our last episode, we removed the PC board from the old amplifier, inspected it and polished it back up, and installed it into the new amp and wired it in accordance with our new color code schema. We also wired the front input sockets into the amplifier, as well as the bias measurement sockets on the front of the amp, which also included the upgraded bias for the individual sockets as part of the upgrade kit provided by Dynakit. Upon completion of all of the wiring, everything was re-inspected, it was dressed, and it was laced in to bring that portion of the project to completion. In this episode, we're going to be conducting a full battery of tests of the amplifier as we're finally able to bring it up with a full complement of components. First, testing that everything that's been installed is operating in the correct fashion. We're going to be using the original manual to look at those original test points, as well as a variety of other tests that will be conducted. We'll be using the HP331 Alpha Harmonic Distortion Analyzer to test the performance of this amplifier with regard to harmonic distortion and frequency response, and seeing how closely it compares to the specifications set forth in the manual. We'll also be hooking it up to some royalty-free music and giving it a good listen. So we have a lot of things to do in this episode. Let's get started. And kick off episode 5 by informing folks, especially those who do not read the comments, that I have conducted after episode 4 an inventory of all of the wires that I have installed to ensure everything is in the correct location, because I do make mistakes. I have found a particularly terrible mistake, which I have posted in that video, and that is here the primary side of the audio transformers coming off. This is the blue and white, for example, a short to ground if you would, and I have rewrapped that connection. So this would be on pins 3 and 4 on all tubes, 3 and 4. It was actually on pins 4 and these two merged pins here, pin 8. Going through all of the other connections, I have not found any other mistakes. However, we're going to make some important tests to make sure that nothing blows up when we turn on this amplifier. In consideration for what could have happened if the rectifier was shorted to ground, which is what would have been through the red cable coming out through the center taps of the primary side, not directly to ground, but I guess pretty much directly to ground through 10 ohm resistors of the bias. Why not simply do a test off of ground to all of the positions on the capacitor and make sure that everything's okay there, because that's going to be a point where failure is going to be spectacular. I'm going to make sure I'm zeroed. Okay, so zeroed out. I'm set at 1 meg per division right now. It's going to be top scale. And I'm just going to go through. Now, this is going through a capacitor, so as I keep this connected, you're going to watch everything slowly drop as capacitor charges. But what we're looking for is we're looking for mega ohms. If this needle goes to 0, we got a problem, we got a short. So here we go. You can see a magnitude of over 3 mega ohms in dropping as it charges. So here's the first one. I'll move to the next one. See 2 mega ohms. Slowly dropping. Third one. Just over 1 mega ohm slowly dropping. And the fourth one. Just under 1 mega ohm slowly dropping. I'm satisfied with these results. I'm going to move on to the next test. I'll be hooking up to pins 2 and 7 and drawing up AC voltage till I get 6.3 volts respective, regardless of what the AC voltage is, because it's not loaded down. This is just to make sure that I don't have any problems as I draw it up. I'm going to be looking at the load on my current meter as some may notice, have put new leads on this unit. It's a little bit safer to work with than the alligator clips. So I start that now. I've got it set on the 15 volt scale as I draw up the power. Yeah, voltage is showing 2 watts. I don't see anything terrible. I'll ramp it up. Showing 4 watts. We sit now at 6.3 volts. Amplifier is drawing 6 watts. Everything seems okay. While this is on and nothing's connected, I would like to do an informal check of the bias circuit. I haven't read up on this procedure yet, but I want to make sure the pots are in good working order. I'm going to start with the top pot on this side here. This one sets this side, so we can see I'm turning it up and turning it back down. Seems to be working just fine. Bring it right here in the center, and then this pot up front has an effect over here. Check the other side, in the front pot. That seems to be working fine. Okay, I just wanted to make sure. I'm going to be doing the same test again, except this time I'm going to have the rectifier in. We'll be looking for 6.3 volts and the sign of anything terrible. So we're at about full filament voltage. You can see the rectifier is heating up now. Monitoring everything, looking at 18 watts, slowly dropping a little bit, 17.7 watts as the rectifier heats up. 17.6, so nothing terrible. 17.5, it's a healthy sign. Now at about 17.4, 200 milliamps. It's only taken 104 volts AC to get this to where it is because we're not under a full load. I look at pins 3 and 4. I'm seeing about 485 volts. However, this is not loaded down. This is a good sign. This is our high voltage we need for the plates. Also several pins for the 7199. I can see 400 here. Obviously these are not yet to scale. This is just checking. 360, 400, 470. So we have voltages going to there as well. It's worth noting, as I pointed out in a previous video, how long it took the amplifier to discharge during testing when it wasn't completely assembled and it had no path to ground from the filter capacitors. We can see the amplifier is sitting here at 480 volts DC, and I flipped the switch on the Variac and we can watch it dropping now. It's at 350 volts and dropping. Definitely much safer to work on once it's fully assembled, and there is a path to ground through resistor. Now at 200 volts. 150. 100 and dropping. So in its current state right now, shut off, disconnected, this amplifier in and around, I don't know, a minute or so is already at 50 volts. Pretty much safe to work on. The next thing that I'm going to be testing is I'm going to be bringing the amp up again, except this time I'm going to be putting in the phase inverters. I'll do the left channel and then the right channel. Also, the expected AC voltage will be a little bit higher due to the extra load. So I'm going to put these in now. I have the signal generator set for 2 kilohertz, currently plugged in the left input. As seen here, the oscilloscope is connected off of the outputs of the phase inverter. Though the phase inverter is floating, it's going nowhere. Turn it on where we left off. Seeing just under 6 volts. I'm going to crank this up. So we go back at 6.3 volts, and the AC is now at 109 volts line voltage. I also don't expect them to be the same size because the probes are not identical. I would have to move one probe onto one probe onto the other to look at these, and that's just not going to happen. I already know that. So just bringing everything into focus and keeping in mind that the probes are not calibrated, so you're going to see slight differences in the probes. That's the left side right there. And I'll bring it over to the right side, and there's the right side right there. So that's the phase inverters. We'll move on to the next step. The next step will be the finals, power tubes, as it were. Before we do that, we have one important task to accomplish. What I want to do right quick is increase the bias on both channels. I really don't know how this is going to react yet. So what I want to do is limit the current flow of the tubes before I get the tubes in. It's sort of a guesstimate, if you would. I'm just putting the brakes on it to the best extent that I know how. I really don't know what the balanced one would be. But as for the top one, that's what I'm going for. I'll do that on the other side as well. And now I know that when I put the tubes in, the minimum amount of current is going to flow because I've got the maximum bias. I'm going to prepare this event with shorting plugs. These are shorted to ground. I'll put them on the inputs. This will stop any noise or what have you from getting in the front end of this amplifier. Also, for good measure, I'll be adding my 8 ohm 100 watt bricks on the back of the output transformers. The resistor blocks are now installed on the outputs. I'll also be adding my usual current meter to one of the tube sockets. I just want to see how it corresponds with voltage and what have you to the milliamps myself. And with that, I'll now repopulate the tube sockets with the finals. We're ready to go. We're going to try and match up the values that we're going to see on the voltmeter against the parameters that are listed here in the instruction. See how close we come. What I'm going to be setting it to is probably 45 for this original test event right here for 45 milliamps. Before I get started with this, I can tell you the preliminary checks have showed that reflowing of this solder is going to be crucial. There were some weird problems that I saw on this board. I've solved a few by reflowing the solder on the connection. Some of them are going to be here like up top that I didn't see because it was upside down. You see how terrible that is? Some are going to be on the bottom. I'm going to do that now before I continue. I've gotten everything biased to a safe level right now. As you can see, we're looking at 48 milliamps, for instance. And the first thing I'm doing is just checking each individual tube socket for corresponding current to voltage reading. I'm noticing that there is an improvement as it heats up. Maybe the value of the resistor changes, brings it into tolerance. I'm not sure. Right now we're looking at the back left tube here, and we're seeing 48 showing 486 and a slight fluctuation. I'm going to let it sit a little longer as I do see an improvement. You wouldn't flip on an amplifier and immediately start taking measurements anyway. So I give the benefit of the doubt, and I'm going to come back in a few minutes. As far as I'm concerned, the third digit within a 10 is spot on. We're looking here right now. We're off by just 3 digits on the 10, depending on what you look at the 10. So I'm going to move to this tube now. Again, the front one's spot on, perfect. We're going to take a look at the other side now, and we're going to see how well that one is. I really want to make sure so I can use this to check the balancing and the bias and not have to depend on the inline. That's the whole purpose of doing this first. This tube up front showing perfect. We're going to move to the back one. This one is off by around 0.7. This is probably the worst of all of them. I'm being extremely petty here because none of this really matters. It's 47 is 47, and it's really good enough for me. So that concludes this portion of testing. I think we're ready to bias at this point. Nothing about this system makes the biasing easier. Remembering that adjusting this channel is going to affect that channel, and that channel affects this channel as you try and get this number where you want it to be, and then you're going to have to balance this, and affecting the balance of one is going to affect the other. I'm going to demonstrate this effect by actually plugging this into the other one. One's voltage and one's current, but you know, the whole purpose of this one, the premise is obviously that one goes down and one goes up. If you had 2 voltmeters, this would be really, really quick. There you go, balanced. However, balanced is all well and good so long as the voltages are right. And if I want this to be 45, I'm going to have to drop down the total voltage. I'm going to have to adjust the bias here up front. So I'm doing that now. Now it's absolutely where I want it to be. We got both at 45 milliamps. Absolutely perfect. Problem is, as I'll demonstrate, and I don't have anything plugged in, as I move over to this set of tubes, just for example, and this one's 48 and plugged in on the other side, and I say, oh, I want to lower this one. When I lower this one, it's going to raise the one on this side. So it's a back and forth. So you can see as I'm dropping this one, down to 45. This one jumped up to 46. So that one's 45, and I put it in the other jack on this side. And I had balanced out before, so it's pretty much even. And the problem is this one's now left with 46. Right, so you can see 45.5. And obviously this jack that I'm in is 46. Now I have to lower this one. Which again is all well and good, but now that raises the other one slightly. So you're slowly dialing it in till you get both of them where you want it. So these on this side should be back down to 45. So I got 45 and 45. Now look at the other side, which should have gone up a hair. Actually, that's just fine now. And I got 45 on that and 45 on that. So all four tubes now 45 milliamps within just a fraction of a tenth. Perfect. Biased. Done. So I'm just starting to bring it up right now to some simple tests. We can see I've got it hooked up to the phase inverter. Got 4K signal going through. And it's never going to match up perfectly on the oscilloscope because of the probes. Probes are never exactly the same. It's very close, but not exact. I'm going to bring this over to the other side and have a look, see how that's doing. We can see that this side is looking just fine too. Looks to be the same amplitude, same characteristic. The input's looking okay. Move onward. Notice how the current shot up on the tube now that we're no longer on idle with that sine wave going through there. 59.8 milliamps. Pull it out. Back down to 45. Here's a test that I like to conduct on amps that are completed. I've shut off all unnecessary electronics, and I've removed one of the 8 ohm bricks on the left channel, and I've hooked up my speaker here. I still have the shorting cables in the front, and I just give a good listen and check to see if there's any hum coming from the speaker. So I put my ear up to it, and I'll put it up to the mic in just a second. I could barely almost make out an audible hum coming from here. I'll try and get it up to the speaker so best as I can. It's on the camera now. And I want to point out that even though I could barely hear it, it's not on the input, the hum. It's not going to get louder as the music gets louder. This is the hum that's in the amp that you have to stick your head up to hear. It's also, all the amps are a little bit noisier when I have them going through the Variac. So removing it from the Variac will further reduce that hum. So I'm very happy with that it's irrelevant. It's so low. I'm just going to go to the other channel and make sure it's just as low. And now hooked to the other channel, it has the faintest hum, the same loudness, if you would, as this channel, calling that hum test a success and completed. And now for something completely different. We're going to start all over with the brand new ST70. Just kidding. Here's the bottom of the amp. We're going to put on the little feet on the bottom of the amp. Then we're going to put the cover on. I have to peel away this safety plastic material. I'm not peeling it to remove it, mind you. I'm just peeling as much as I need to get the job done. Just like that. There we go. Let's have a look. So the bottom cover now has all the feet on it. We're now going to put the amplifier over the bottom cover and screw it down. When all tests have been completed and I won't be removing the cover on and off 20 times, I'll remove the protective backing here. Time to restage for the next event. Just starting to get things set up here. Testing out the equipment is the 331 harmonic distortion analyzer. And right now, I just have my function generator plugged directly into it at 4K, looking at 0.23% total harmonic distortion. I'm going to go through a couple cycles, make sure that, number one, this is working good, as well as this machine before I get started testing this. I don't have $10,000 worth of modern THD equipment, so I do what I can. Not having enough test equipment on the bench at one time, I realized that I did not check the EL34s to find out which pairs were going to go on which sides. I wanted to take a look at the emissions of the tubes to see which ones were going to be paired together. I'm going to do that now. This one's reading 5600 Mohs. This one reads 5700. This one just about 5,800. This one was about 5,500. So we have 57, 56, 55, and 58. So we're off by 100 on this side. We're off by 300 on this side. But if we swap the back two, we'll only be off by 100 on both sides. So I'm going to do that now. Now the channels are better balanced. I will go through one iteration of this test very quickly. I have to do a lot of this over and over again. I'm not going to include all these in the video. And this is not done with the strictest adherence, with the strictest shielding. What it does do is it does compare the left and right channel to see how close they are aligned to each other. Just getting into it. Right now I'm on 1,000. I already know how much distortion is in this, as I said previously. And now that I have 1,000, I'm going to come on over to the amplifier. I know that when I plug into the amp, I'm going to want to see 11.3 volts RMS on the output. That's 16 watts. So I'm going to adjust my power supply to ensure that I get 11.3. So I plug in. As it turns out, right on the money, we're seeing 11.3. Once I establish it, I'm going to remove these leads. I don't want them connected during the test. I could have just as well used the RMS meter on here. Now I set my set level for 100%. That's set. Flip it over to distortion. And now I'm going to tune it in. We'll be able to watch a needle drop and the sine wave get nulled. And we're all the way down at the bottom now. We can barely see it. So we will set our range. I'll use the finer adjustment. Set our range again. Now I'll use the balance. I only have so much time because that resistor is going to start to get hot. Set my range again. Look over here, we're seeing about 0.38 total harmonic distortion. Before anything else, I cancel the test and I pull this cable so I don't cook my resistor. Now I can record the value. Using this half power value that I've chosen, I record the values for the harmonic distortion for each one of these given frequencies that I've put into this table so that I could then convert it into this graph that's shown here. Looking at this graph, one of the most important things I'm looking for is consistency between the two channels. We could see here that they're pretty much identical, which tells me that there aren't any problems in one of the channels, or both of the channels for that matter. Their properties are pretty much the same. The other thing worth pointing out is the cables that I'm using between the amplifier and the analyzer are terrible. They do start to have issues as the frequency increases above a couple of thousand hertz, and we see that here demonstrated. It's not really a problem for me in this test. I'm just really looking for consistency, and I'm fine with that. This is the most subjective portion of the whole project. This is the listening portion. It can be difficult to obviously do this through the camera. To aid this effort, I have procured a directional microphone. I'm going to show you how I have the speakers situated, and the direction of how this camera is set up on the tripod is going to be done in a manner that lends itself towards the microphone positioning, not so much the positioning of the camera, as they're kind of tied together. I'll show you what we've got. We can see up here in the top right is a speaker pointed down towards the middle. Here where the tripod is located. Same thing is going on here on the left-hand side. The tripod will be in the middle pointed forward, so it will be evenly distributed to the greatest extent possible. Royalty-free music for today's testing has been provided by bensound.com. As required, the links and information for each one of these songs has been provided in the comments below. Before I begin with the audio testing portion of this project, I would like to thank everybody who joined me for the last 5 episodes. It's been a very rewarding project. I'm glad that I was able to restore this amp to its former glory. I will be doing other videos after this as the need arises for other projects that will both contribute to this amplifier as well as projects that this amplifier will contribute to. I hope you enjoyed this video and this series. I found it helpful, entertaining, and insightful. Please hit that like button below. Helps me a lot. Thanks for watching.
Thanks for watching. Would you like to reply?